Hello everyone, this is grade 10 physics, practice 2b on page 42. Now in the previous video I talked about sample problem 2b, which is in the upper part of page 42, but this is the practice 2b. Don't get it confused with the sample 2b, this is practice 2b. On page 42, it's right in the middle of the page, alright? So in the upper part you have sample problem. In the lower part, you have section review, but right in the middle, you have practice 2b, page 42. All right, so we have two questions in practice 2b. Let's solve both of them. I'll start with the first question. The first question, it says, a metallic wire of diameter 1 millimeter and length of 2.3 meter is made of copper of Young modulus 1.1 times 10 to the power 11 Pascal. So that's the information that's given in the book. Let me write down the information here. This is my given part. These are all the information that I have. The first information that I have is a metallic wire of diameter 1 millimeter. So my diameter D is 1 millimeter. So that's my diameter. The second information that I have is the length of the wire. The length of the wire is simply the initial length. When I say the length of the wire, I mean its initial length, right? So my initial length is 2.3 meter. That's also given. The final information that I have is Young modulus, E, which I call it Young modulus. And the number for Young modulus is 1.1 times 10 to the power 11 Pascal. That's the unit for it, which is n over meter squared. All right, so this is the given part. What is required? What is the unknown? The unknown, I have two unknowns. First, A, it says calculate the cross-sectional area of the wire. Simply calculate the area of the wire. Simple. Just find A. Find the area of the wire. Now the equation for area, which is a mathematical equation, it is just simply pi multiplied by r squared. Okay? Pi multiplied by r squared. You always have pi. Pi is always 3.14. What you don't have here in the given is radius. I don't have radius, but no problem. I have diameter. Okay, if you have diameter, you can change diameter to radius. And how do you change diameter to radius? Well, simple. I'll just solve it here in this little corner. The equation for radius, how do you find radius? Well, you simply divide diameter by 2. Divided by 2, that means change your diameter into half. Radius is half of the diameter. Alright, so what is my diameter? My diameter is 1 millimeter. Divided by 2, what you get is 0.5 millimeter. That is the number that you should get. 0.5 millimeter. So this is your radius. But I don't want it in millimeter. I would just like to change it to meter because my initial length is in meter. So if I change it to meter, it will make my answer simpler so that my units can match. So I'll change 0.5 millimeter. I'll change it into meter. And if you do the conversion of units, you will get 0.5 times 10 to the power negative 3 meters. This is your number. This is your radius. Very simple. You just simply find the radius by dividing your diameter, and then I change the units. Alright, so let me put down the number here because now I have radius and I know pi. This way I can find area. So area simply is 3.14, my pi, multiplied by radius. And what is my radius? I just found it. 0.5 times 10 to the power negative 3 squared. Don't forget this squared here, guys, because the information that I have in this equation contains squared. If you forget the squared here, the whole answer will be wrong. Alright, so you just put this number in the calculator, insert those numbers in the calculator, and the answer that you should get, if you do your calculation, the answer that you should get, let me see, it should be 0.785. This is the number that you should get if you put it in the calculator. 785 times 10 to the power negative 6 meter squared. Sorry about this ugly meter. This is meter. Right, let me write it down again. Meter, I'll just write it here. Meter squared. So that's it. This is the number that you get. Why is it meter squared? Well, because it's area. That's why you get meter squared, because it's area. This is the job for this squared here. Once you have the meter, you square it and you get meter squared. All right, so this is the answer for A. Let's go to the second part, which is B. Calculate the strain in the wire for an elongation of 0.85. So now we have one extra information in B, which it says the elongation of the wire is this is elongation, L final minus L initial, together they are called elongation, equals to, it's given in the B part, which says 0.85 millimeter. That's the elongation that I have. Now, of course, I would like to change this millimeter into meter, so I'll simply change this to meter, 0.85 times 10 to the power negative 3 meter, because milli is negative 3. So this is how you change your elongation, which is in unit of millimeter, how you change it to meter. All right, so what it says in the B part of the question, it simply says find the strain. So B here, it says find the strain. Now you know the equation for the strain, which is epsilon equal to elongation, L minus L naught, divided by initial length. What is our elongation? It's given in the B part. We just talked about it. It is 0.85 times 10 to the power negative 3 meter. So let me write this down here. The elongation is 0.85 times 10 to the power negative 3 meter. That's my elongation. What about my initial length? Well, my initial length is also given. If you look up here, this is L naught, my initial length, 2.3 meter. So that's my initial length. Let me put this down here in my equation in the denominator. So I've got 2.3 meters. Now this meter will go with that meter because one is in the numerator, one is in the denominator. They look like each other, they cancel each other out. And if you divide those two numbers, 0.85 times 10 to the power negative 3 divided by 2.3, the answer that you should get will simply be, what is the answer that I should get? It should be 0.37 times 10 to the power negative 3. And what is my unit? I don't have any units because strain is unitless. Why is it unitless? Because it's the ratio between the same two units. It's the ratio between meter with meter. They cancel each other out. The answer will be unitless. All right, so I think solving those problems are very easy. We solved both of the parts, A and B.